Today you will be looking at solving inequalities with variables on both sides. Just as a quick review, let's look at our inequality symbols and what they mean. If you have something on this side, it would be greater than whatever's here. This would mean that whatever's on the left is greater than or equal to what's on the right. Here would be showing that whatever's on the left is less than whatever's on the right. And our last symbol shows that the left-hand side is less than or equal to the right-hand side. Greater than meaning bigger, a bigger number. Less than meaning smaller. A quick review so you know how to set up your notebook. Remember, you want to title it 2A, Solving Inequalities with Variables on one side. And then you need each of the following things in your notes. The first thing you need is the flip rule when working with inequalities. The second thing you need is solving a one-step inequality, and there are 3 examples you should have from here. The third thing is you should have 2 examples of solving 2-step inequalities. And the fourth thing you should have is 2 examples of solving multi-step inequalities. So go ahead and get your paper set up, and when you're ready, keep going to the next slide and be ready to start taking some notes. So first off, let's remember back to when we solved equations. Okay, when we solved equations, we had one-step equations where you just had to do one operation to solve. We had 2-step equations where we had to do 2 operations, or multi-step where we had to combine our things first and then do 2 steps to solve. Well, solving inequalities is basically the same thing. We're going to go through the same process using the same inverse operations to solve each inequality. Meaning that addition undoes subtraction, multiplication undoes division, division undoes multiplication, and subtraction undoes addition. So make sure that you reflect back on those notes and when we originally solved equations, because that will help you greatly during this video. The flip rule in solving inequalities. It says that whenever multiplying or dividing by a negative number, you have to reverse the inequality symbol. For example, if we have the inequality negative 3n is greater than 12, we have to divide by negative 3 on both sides, and we have to reverse this symbol. So instead of it being greater than, it's now less than. The symbol flips around. So that's why we call it the flip rule when solving inequalities. Let's look at a few examples. When solving a one-step inequality, as you can see, we'll go from left to right. In our first one, we have to add 9 to both sides, and we get x is less than 26. On our second one, we have to divide by negative 5. Well, remember, when multiplying or dividing by a negative number, you have to reverse that inequality symbol, so we flip it around and get x is less than or equal to negative 4. On our third one, x divided by 4 is greater than 7. We multiply by 4 on both sides and get x is greater than 28. Solving one-step inequalities is pretty simple. Let's take a look at solving 2-step inequalities. In a 2-step inequality, we have to go through 2 parts. So here you can see our first step is to subtract 2. Then we get 3x is greater than or equal to 9. Divide by 3 on both sides and get x is greater than or equal to 3. We're good there. In a 2-step inequality, we have to first, in this case, add 4. So we get negative 2x is less than 14. And we're dividing by that pesky negative again, so we have to flip our inequality sign. So instead of it being less than, it's now greater than, so we get x is greater than negative 7. Those are 2 good examples of solving 2-step inequalities. Now let's look again at solving multi-step inequalities. In this first multi-step inequality, remember, we underline all the things with x's, so 2x plus 1x makes 3x, and we circle all of our numbers, so 10 and negative 4, so 10 minus 4 gives us 6. So we get the inequality 3x plus 6 is greater than or equal to 9. If we subtract 6 from both sides, we get 3x is greater than or equal to 3. Then we divide by 3 on both sides and get x is greater than or equal to 1, because 3 divided by 3 is 1. Simple. In our second example, again we underline all the things with x's, so negative 5x plus 4x is negative 1x, and then 10 minus 1 gives us 9, so we get negative 1x plus 9 is less than 30. We have to first subtract 9 on both sides to give us negative 1x is less than 21. And our last step, remember we're dividing by that negative sign again, so we have to remember to flip the inequality to give us our answer of x is greater than negative 21. Make sure you guys have each of those slides with both examples for one-step inequalities, both examples for 2 steps, and both examples for 3 steps. And bring them to class tomorrow so you're ready to go. Have a great night, guys.